All right, welcome to Wednesday. Hopefully you didn't have too much problem with that homework assignment. It was basically just rectangular prisms. Okay, so let's go over the answers here. So each one has how many? 1, 2, 3. So each one of these, 1 through 6, has 3 answers. I'll basically call them out in order. All right, number 1, the lateral area is 40. The total area, or the surface area, is 88, and the volume is 48. Notice once again, they're really lazy. They don't put units. All right, number 2, lateral area is 2,400. Surface area or total area is 5,400. And the volume is 22,500. Number 3, the height is 3. The lateral area is 54. And the total area is 90. Number 4, the length is 9. The lateral area is 170. And the total area is 314. Number 5, the width is 6, the total area is 168, and the volume is 108. Number 6, the lateral area is 54x squared, the total area is 94x squared, and the volume is 60x cubed. Number 7, the total 7 through 12 only have 2 answers. Number 7, the total area is 54 and the volume is 27. Number 8, the total area is 6e squared, and the volume is e cubed. Number 9, e is 10, and the total area is 96. Number 11, e is 5, and the volume is 125. And number 12, the total area is 24x squared, and the volume is 8x cubed. All right. Number 13, 390. Number 14, finally some units, 8 centimeters. Number 15, 2 answers, 4 and 8. Number 16, 3 answers, 9, 9, and 27. All right, here we go, special right triangles. Number 17, 240 is the lateral area. The total area is, in other words, the surface area is 240 plus 32 root 3. And finally, the volume is 160 root 3. Number 18, lateral area is 360, total area 468, and volume is 540. Number 19, lateral area is 252. Total area, that can't be right. Hold on. Oh, okay, I see it. Lateral area is 252. Total area is 372. And volume is 420. All right, that makes sense. And the last one, lateral area is 480. Total area is 536. And the volume is 560. Wow. Okay, hopefully you understand how to calculate the volume of a rectangular prism and the surface area, or as the book calls it, the total area. All right, by the way, answer question number 1 on Google Forms. All right, we're moving on. Quiz on Monday, tomorrow, or Friday. I will tell you what will be on the quiz. This is basically going to be 12-1, 12-2, 12-3. Okay, so 12-1, volume and surface area of a prism or total area of prisms. And then what we're doing today, which is, I'm flipping pages here. Oh yeah, pyramids. We'll do pyramids today, both volume and surface area of pyramids. And then what we do on 12-3, which is, what shape are we doing? 12-3, is it cones? Yes, cylinders and cones. Okay. All right, here's your homework tonight. Pyramids. Cool. Pyramids. It's basically a repeat of what we did for prisms. We're going to talk about surface area, total area, lateral area, and then we'll talk about volume. All right, write this down, please. So the definition of pyramid, man, they made this very complicated. The definition I use in pre-algebra is perfectly fine, but this is more using far more math speak language to give the definition. It is correct, by the way. It is a polyhedron. Remember, polyhedrons are three-dimensional shapes made up of polygons joined at their edges. So it's a polyhedron with a polygonal base. That means the base of the pyramid has to be a polygon, can't be a circle. That would make a cone, by the way. And then the lateral faces are triangles, right? And those triangles meet at a single point. Okay? And that's the definition. So it's a polyhedron with a polygonal base, and the lateral faces, in other words, the sides, are made up of triangles, and those triangles meet at a single point. So let's see, the base is a polygon. In this case, it could be a rectangle or a square, and the sides are made of triangles. Now notice all those triangles meet up at one single point. Obviously, it's called the vertex. But compare and contrast this to the prism. Remember, a prism has, well, it has polygonal bases as well too, but the sides are parallelograms or rectangles. Okay, but the sides are triangles. All right, so we're going to name the parts of a pyramid. So here is, let's see, that is a. Oh, by the way, pyramids are named after their bases. So this is, well, it's got 5 sides. This is a pentagonal pyramid. Pentagonal pyramid. Okay. So the parts of the pyramids, well, first off, is that base. It's what defines the shape the shape itself. The definition is a polygon that all the lateral faces, that means the sides, and they share a common edge. In other words, all the faces meet at the base. Okay, that's called the base. The sides we call not sides, we call them lateral faces. These are the triangles that form the sides of the pyramid. Remember, if they were rectangles or parallelograms, this would be a prism. Next one is called the vertex. Obviously, the vertex is where the lateral faces intersect at the very tip. And then we have the altitude. Once again, the altitude is the perpendicular distance from the base to the vertex. Okay, and that's that little red dotted line right there. Perpendicular distance from the base to the vertex. Once again, we use the word altitude and height interchangeably, so that distance is also called the height of the pyramid. So that's a pentagonal pyramid. Here's a hexagonal pyramid, same idea here. There's one other thing that we're going to add. Notice that extra little red line that I added to the shape. If you could imagine yourself walking up the side of this pyramid, right, from the middle of the base to the vertex, that distance, well, that's not the height. Generally, most math books use the letter L to represent this, and that little L is called the slant height. If you had me for pre-algebra, you're very well aware of slant heights. So slant height is, well, it's also a perpendicular distance, but it's not from the center of the base. It's from the edge of the base, the center of one of the sides of the bases, to the vertex. So we basically have 2 heights, and that's probably why they also use the word altitude there, so it's not too confusing. But I will say this, height or altitude usually has the letter H to represent it, and slant height has the letter L to represent it. Okay, so those are the parts of the pyramid that we will be dealing with today. And our book does a pretty good job of always calling the vertex V, the altitude H, and the slant height L. Now there are a couple different, or 2 flavors of pyramids. The first one is it's your general one that you think of the shape when you get a pyramid. I don't mean like pyramids of Giza, I just mean a normal looking pyramid. And that pyramid is called a regular pyramid. So here's what a regular pyramid has. One, it's got a polygon base, but that base is also a regular polygon. So it's not just that it's a hexagon, or it's not just that it's a square, it's a regular shape. So if it's a hexagon, all 6 sides, all 6 angles have to be the same. If it's a quadrilateral, the only regular quadrilateral pyramid is a square pyramid. Okay, and you certainly do have a triangle. I think tonight for homework they gave you triangular, square, and hexagonal pyramids. All right, some other things. Notice the lateral edges. Look at the sides of the pyramids where the triangles meet. Not at the top, the vertex, but on the sides, right? All of those little line segments right there, the sides of the triangles, we call those lateral edges, and all those are congruent, meaning they have the same value. Also, all of those triangles are congruent, right? And there are isosceles triangles at that. And then lastly, for a regular pyramid, the height or the altitude goes from the center of the base to the top, to the vertex, where the triangles meet. So that's a regular pyramid. We also had regular prisms, remember? What was the other type of prism we had? Now, for those of you that remember, that was called an oblique prism. Well, we have the same thing for pyramids. Notice here, those triangles are not the same size. Notice the altitude or the height of the pyramid doesn't come from the center of the base. And then notice that the edges, the lateral edges, would not all be congruent. We call this an oblique pyramid, okay? For construction, most of the time you'll see regular pyramids. You will not see oblique pyramids. Okay, so those are the two types. So we're going to play, I think, 2 games today. The first game is to calculate the slant height. Not a very challenging thing to do. Calculate. So the most challenging thing is to make sure that you understand where the slant height is. Well, there's two methods basically of and I don't mean like you can choose either one. It depends upon what information you're given. But there's 2 basic ways that they will, or the two basic things that they will give you, and then when they ask you to calculate the slant height. So once again, here's the picture here. We're trying to calculate L, right? How long is L? 2 ways that this can happen. One, they'll give you a pyramid, and by the way, they're only going to give you regular pyramids for this. They give you a regular pyramid, and they give you one side length, right? So obviously, this one, if it's a regular, that means that's a square for the base, and they give us one side length of 10, so that means the distance between O and M must be 5 because it's a square, and we know that for a regular pyramid, the altitude is measured from the center. So we know that that side there of that little triangle that I just made, the yellow one there, has to be 5. It's also labeled on this diagram. Okay, look at one of the lateral faces of the triangle. Notice, well, we know that it's an isosceles triangle, the lateral face. Therefore, if one side length is 10, then the 2 individual pieces parts that make up that side would be 5 and 5, okay? So here is the first, I don't know, flavor of this, right? You are given neither the height nor the slant height, but you are given the bottom of that right triangle, okay? So for this particular one, well, I can't calculate the height or the slant height for this one because I only know one side of that yellow triangle that's formed right there. So I got to do this a different way. And the different way is to, I'll color it blue, is to look at one of the lateral faces. And if I draw that lateral face off to the side, basically I get that particular one. What I'm actually calculating in there would be the distance between V to the bottom, right? The perpendicular distance, that would be the height of that triangle. And we can do that now because, check it out, I have 2 right triangles there and I have 2 of the sides. I can just use the Pythagorean theorem, and that would be the L. So the dotted line and the line L are one and the same. Can you see that? All right, so we just need to apply the Pythagorean theorem to this. I won't bore you with the Pythagorean theorem details, but suffice to say, you just basically do the Pythagorean theorem and you find out that the slant height for this one is 12. Okay, so this is one of the cases where you're asked to calculate the slant height, L, but you're only given one side of the pyramid's base. Does that make sense? So you don't know what the height is, and obviously you don't know what the slant height is. In order to do this, though, they have to give you a side and they have to give you a lateral edge. Notice I was given 10 and 13. So if you're given a lateral edge and you're given a base, now they went further and broke that 10 down to 5 and 5, but they could easily have just said one side length of that square pyramid of the base is 10 and the lateral edge is 13. Now we know it's regular, so that means that all the lateral edges are 13. Okay, makes sense? The second way this can happen is if it's like, this is a different pyramid, by the way. The numbers look similar, but they're not. So this one, I'm given the actual height. I'm not given the lateral edge. Remember last time we were told the lateral edge was 13. This time I'm not given that. I'm just given the height, and I'm given the side distance of one of the bases, which they further break down. Take half of that as 5. Because remember, the perpendicular distance goes from the middle of the base for a regular pyramid. Okay, but once again, this one is still, it's straight out. I don't need to draw another triangle for this one. It's just the yellow one to calculate the slant height here. It's still Pythagorean theorem, just a little different version of it. And so you solve the Pythagorean theorem and you get to the slant height again. Those are 2 different, those were not the same pyramids. Okay? If you need to, watch those 2 again, those 2 examples. So that's the first game, which is calculate the slant height. There's 2 different versions of it depending upon what information you were given. The second game is to calculate not the slant height, but the height. I'm going to go back to that first pyramid. This is that first pyramid. Okay, so I want to calculate now the height of this pyramid. Well, if they're given this, if you're given the side of the base and you're given the lateral edge, this is a two-step process. The first step is, well, see that yellow triangle there? You got to calculate the slant height. Well, to calculate the slant height, you did what we just did in that preview, not the one we just did, but the one before that one. What did we find out that the slant height was? Well, we found out the slant height was 12, right? So we found out that the slant height was 12, okay, from the previous one. Now I can calculate the height of this one, okay? I'm still going to, at this step, use the Pythagorean theorem. So this is like a two-step procedure where the first one tells you the slant height and the second one will tell you the height. So this one requires a bunch of work here, but it's still basically an application of Pythagorean theorem. So we do the Pythagorean theorem and we get to an answer. This one's not very interesting. So the exact answer is root 119 and the approximate answer is about 10.9. I'm trying to flip through the book real quick to see what they say. Exact or approximately, find numerical answers. I'm looking at all the answers. Look like they gave me exact answers for, oh, that's classroom, sorry. Yeah, for written exercises as well, it looks like they stuck to exact answers. So even though I'm going to show you approximate answers tonight for homework, if you get square root of 119, leave it as that. Okay. So let's now switch gears and let's do lateral area. Remember, lateral area will be the sum of the areas of the sides of this shape. So basically, all the triangles added up together, excluding the base. If we include the base, then that would be the total area, in other words, the surface area. So the lateral area of this pyramid would be all the triangles added up. And I want you to ignore the yellow triangle to get your head wrapped around what I'm asking you to calculate. So basically, the lateral area would be those four triangles, exclude the yellow one, all added together. So let's see, how could we do that? Well, we first need to calculate the area of one of those sides, lateral faces, of the pyramid. So I'll draw one below. Using the information we already calculated, we found out that the slant height was 12. And then we know that the lateral edges are 13. We're given that. And we also know that the side of the base is 10. We were all given that. So I can easily calculate and remember, I'm not calculating the yellow triangle right here. I'm calculating the side of one of the sides of the pyramids. Okay? So let's see, what's the formula for a triangle? Base times height divided by 2. Let's see, the base is 10. The height is 12. That's a pretty easy calculation to do. So we get, what, 60? And what we have 4 sides, so that would be 4 times 60, in other words, 240. And remember, we're doing area, so square root. This is not the surface area or total area. This is just the lateral area. If we add the base to that, so let's see, the base was a square, so 10 times 10 is 100. So we get, what, 340 square units would be the total area. But in this case, they only asked us to do the lateral area. So that's pretty simple. Yeah. Well, it turns out that there's actually an easier way, and you're like, well, this wasn't that hard, but it turns out there is an easier way. Let's think about what we just did. So on the left there is what we just did, and obviously it did get us to the right answer. But let's think about the definition of a regular pyramid. One of those things that you wrote down was that all of the triangles are congruent, right? So if all the triangles are congruent, that means that all their bases of the triangles are exactly the same. So if we know that one side is 10, and we're doing this for 4 triangles, then basically we're doing the perimeter, right? Think about that. Eventually we're going to have to multiply by 4, so why don't we do that right from the start? Well, in other words, that would be the perimeter. Right? If it was a pentagonal regular pyramid, right, it would be 5 times one of those bases, 6 times for hexagonal. So if we just plug in the perimeter, right, we'll never have to do that extra multiplication. So we do the perimeter times the what? Well, still times the L for slant height, right? Because that's where we get the height of one of the triangles. And then we still have to divide by 2. So this is the actual formula for the lateral area of any, but this is only for regular pyramids. Okay, it has to be a regular pyramid. So this is the formula, which specifically says take the perimeter, multiply by the slant height, and then divide it by 2. So we could debate whether or not this is easier than the step that we just did. I mean, it saves us one step, basically. Okay. Before we had to multiply that 60 times 4. Now we're incorporating that into it. And you're like, well, I still have to calculate the perimeter, so I would agree that it doesn't really save you that much time. However, this is the formula that everyone uses. Okay, so the lateral area, and this, remember, only for a regular pyramid. You're going to get this as a theorem here in a second. Is PL divided by 2, where P is the perimeter, the base, right? And then L is the slant height. Okay, so let's write that down. This is theorem 12.3, and it simply says that the lateral area of this only applies to regular pyramids, is equal to 1/2 of the perimeter of the base times the slant height. In other words, PL over 2. Now, if you need to hear that again, rewind, watch those 2 slides again, and then email me if you're having problems with this. Should be pretty simple, though. Okay. Next idea is not a proof, it's just a video. Prism is base area times the height. So if 3 of those rectangular pyramids make one rectangular prism, I simply take the formula for rectangular prism and divide it by 3, and that's the formula for volume of 1 for one rectangular pyramid. Okay? We do need to label the parts here. So capital B stands for base area. H stands for the height of the pyramid, and obviously divide by 3. Okay? So that is theorem 12.4. It's the only other theorem we're doing today. So we had 12.3, which told us the lateral area of a pyramid, and 12.4 tells us for volume. Okay? Pretty easy one to use. However, do you think they're going to give you an easy or a hard example to do? If this was pre-algebra, we would jump right in and these would be easy. You guys wouldn't have any problems with it. Unfortunately for you, you're in high school geometry. They're going to give you a... Okay, so let's see what we got here. So we got a hexagonal pyramid, and it says it's regular. We're given one side distance, and we're given the height. The height is 12. Okay, so buckle your seatbelts. This one's very challenging. All right, so it says calculate the lateral area of the pyramid, regular pyramid. So before you freak out, and you should, because this one's challenging, well, let's think about it. Theorem 12.3 says that the lateral area of any regular pyramid is the perimeter of the base times the slant height divided by 2. So perimeter of the base, we got nothing. We don't have the perimeter. There's no values there. L is a slant height. We don't know what that is. So in other words, we got nothing for this one. I do need to figure out, though, so I need the perimeter. In other words, I need the distance of AC or CB or AB multiplied by 3. That would give me the perimeter, right? Well, somehow I got to get to that. I also need to solve for L. So in problems like this where you kind of know what you need to do, I need to find the perimeter, I need to find the slant height, but you're unsure of how to get there, try to figure out what you can immediately, remember when I always say, what can you immediately tell me, right? So look at the values that you're given and what can you immediately tell me? Well, you can immediately tell me that look at triangle AVO, right triangle, AVO, right triangle, and we have 2 of the sides, 10 and 6. So we could use the Pythagorean theorem to find AO, So there's that triangle right there just pulled out. We just use the Pythagorean theorem, right, to find the bottom portion there. So that's not too bad. So it looks like that bottom portion there is 8. Okay? Now, you need to remember, if this was a hexagonal pyramid, right, O would be in the center. So that would mean that AM will be half on one side, half on the other side. But that's not the case right here. In this particular case, since it's a triangle base, that O is the midpoint, or it's equidistance from all three sides. We had a theorem a long time ago that said if you're given the height, or I'm sorry, if you're given the center of a equilateral triangle, which that one is, then O is equidistance from the two sides, and it breaks up the altitude. That would be AM. It breaks up the altitude into 2/3, 1/3, meaning the long piece AO is 2/3 of the whole, and OM is 1/3. That's why this one is complicated. Most of you would probably think that AO is congruent to OM. It's not. Okay, that would be true for a square. That would be true for many shapes, but not for the triangle. All right, but we're going to use that information. Okay, so what we can say now is we can say that 2/3 of AM, 2/3 of the whole, is equal to AO. Well, I wrote it that way because I know what AO is. AO is equal to 8, therefore I can solve for AM. I'm going to say that again. 2/3 of the whole, that would be AM, is equal to AO. And I wrote it that way because I know what AO is. AO is 8. I got that from the previous part of doing the Pythagorean theorem. All right, so let's see. 2/3 of, just multiply both sides by 3/2. 3 times 8 is 24. Half of 24 is 12. Therefore, I know that AM, the whole thing, is 12. Therefore, I know OM, right, 12 minus 8 is 4. So I just figured out the small part. Why did I do that? Because remember, I'm trying to find out what L is, right? I'm also trying to find out what the perimeter is. We'll get the perimeter in a second. So I know that, well, I got another triangle there, the blue one, right? So the height is 6, the base is 4 there. Where did I get that from? From that 2/3, 1/3 portion right there. Therefore, I could get L just by using the Pythagorean theorem again. So I do the Pythagorean theorem. I'm doing this quickly, I realize. Now, I get the square root of 52, all right? Don't panic. Square root of 52, let's see, 4 goes into 52. 4 times 13 is 52, so that would be what, 2 root 13? You can leave it as the square root of 52. You just have some reducing to do. Okay, I need more paper. I'm out of paper here. So I did all that calculation, and I found out that the slant height was 2 root 13. So I'm going to erase what I just did. I'm going to plug in that L is now 2 root 13. Hey, notice 2 divided by 2 cancels. So really this is just the perimeter times root 13. So now I need to find the perimeter. How are we going to find the perimeter? Once again, we go back to any of the triangles where we know distances to. So I'll just pick this one. Now I know that the lateral edge, because it's regular, if one is 10, they're all 10. I'm going to draw that blue triangle here to the side. So I know if one lateral edge is 10, they're all 10, right? I just figured out that L on that blue triangle there is 2 root 13. You see where I'm getting those numbers from? Once again, if I got 2 of 3 on a right triangle, I just use Pythagorean theorem. Holy cow, this is complicated. All right, so let's see. I got to solve for the bottom part. So let's see. X squared, square 2 root 13, square 100, square 10. When you square 2 root 13, you get 4 times 13, which is, what, 52? And then subtract 52. I skipped this step, sorry. Subtract 52 from both sides, and we get 48. You understand where I got the 48? 4 times 13 is 52, and then subtract 52 from both sides. We take the square root of 48. What's the biggest number that goes into 48? Perfect square. 16. 16 times 3 is 48. So square root of 16 is 4. So we get 4 root 13. So that's what x is. Why did we want to find x? Because remember, we're trying to find the perimeter of the base of that pyramid. So we know that CM, or MC, is 4 root 3. Since triangle VCB is isosceles, then we know that that part is 4 root 13 as well. Or sorry, 4 root 3. And then 4 root 3 plus 4 root 3 is 8 root 3. Or I could simply multiply that by 3, right? That's one side. Remember, we're looking for the perimeter. So 3 times 8 is 24. So the perimeter is 24 root 3. Dear Lord, that was a lot of calculations. So that's what P is. Go back all the way to the left there. That's what P is. Toss that in. 3 times 13 is 39. And we're done. I got to say, for the entire book, that's the longest problem that I think that was in the book. And that's just an example. Okay. If you struggle with homework tonight, if there's something, please let me know because wow, that one was complicated. So let's end up on a little bit easier one, just to build our confidence. Okay, so it says calculate the volume of the regular pyramid. This is the same pyramid, by the way, that we just struggled mightily to find that AM was 12 and that AC, or any of the sides of the base, was 8 root 3. Okay, so now we're to calculate the volume. Remember, 12.4 is it? Is it 12.4? 12.4 says the volume is equal to capital B, which is the base area, times the height divided by 3. All right, let's see if we can do this one quickly. Capital B or H, which one do we know immediately? We know H. H is 6. 6 divided by 3 is 2. So basically 2 times the base area and we're done. So we need to find the base area. The base area is a triangle. The formula for area of a triangle is base times height divided by 2. See what I did there? All right, so I'm just looking at the bottom. What's the base? Well, we know the base is 8 root 3. And we know the height. The height is 12, so this one isn't too bad. Okay, but remember, this one isn't too bad because of all the work that we previously just did, which was bad. Okay, 12 divided by 2 is 6. 6 times 8 is 48, so we get 48 root 3. So capital B is 48 root 3. Toss that back in on the other side for the capital letter B, so we got 96 root 3 cubic units. Wow. Okay, so if you had a lot of problems like that, I could probably put 3 of those on a test, and that would take you 50 minutes to get to. Hopefully, they aren't all like that tonight for homework, but some of them are. Okay, so obviously, 1 through, say, 10 are the easier ones, and then as you get further along, they're a little bit more challenging. So I'd say 15 and 16 are probably the hardest ones. I think that's right. Okay, so that does it for Wednesday. Remember, Friday I will tell you what will be on the quiz. It's basically just going to be lateral area, total area of, and notice we didn't do an example here for pyramids for total area, but you kind of understand. It's lateral area plus the base area for pyramids. So it'll be total area, lateral area, and volume of prisms, pyramids, cones, and cylinders. So I don't know, maybe 6 questions total, something like that. It'll be multiple choice again. So once again, I will not make them obviously as hard as the previous one. It'll be a plug and chug. Make sure you have your formulas down, and it'll be a calculator test as well too. Don't panic. Okay? So I'll see you guys on Friday. And basically what that video is showing you is that if you start off with 3 congruent rectangular pyramids and you put them together, you make a prism. In other words, a rectangular prism. Why is that important? Well, it's because I know what the formula is for volume of a prism. The formula for volume of